Hi everyone. Today you are going to do your last lesson of the year. The rest is review. We're going to review for Unit 8 and 9, and then we'll review for IEP exams. It's very exciting. For this first thing of our last lesson, of course, we're going to get our warm-up from Canvas, download, print it, open it up, whatever you do usually, and complete this warm-up. This is a review of Unit 2 with residual plots, etc. Remember, you can make the residual plot in Stapplet is my recommendation. Typically won't have to make one on the exam. You just have to analyze it. So just go ahead and let Stapplet do it for you because it can do it pretty quickly. So pause here, complete this warm up, and then we'll come back to go over the answer when you finish. All right, one thing I'm going to add in red here is you always need to define the variables as a reminder, and then the hat means you say predicted. So don't forget that. Here's the residual plot I got from Stapplet. So it has no clear pattern, which means a linear model is appropriate. So remember that rule that we learned. And then a clear pattern would look like, any number of things. So I'll just make sure you guys see what one looks like. Clear pattern examples would be like this, or we call this one a Christmas tree pattern, something like that, where the scatter gets more and more wide. The variability gets wider and wider as your xy's get larger. Those are two examples of clear pattern. Okay, so let's take out the worksheet. How does GPA relate to ACT score? You should be able to do numbers 1 through 3 on your own. So you can pause here and complete 1 through 3, just general review of linear regression with the equation, the table, and then the residual plots. Well, anyway, pause here. We'll go over in a second. Okay, so I would expect the relationship to be positive. As GPA increases, I expect ACT score to increase as well. Don't forget that we don't use these top 3 values in this table. We haven't used these 2 yet, but we will maybe later today, the T and the P. Cross off the adjusted. And then we are defining our variables. And I'm just going to add a reminder of a vocab word from a long time ago. When you take different samples, you expect there to be variability from sample to sample. That's called sampling variability. So, and then let's just say here we have, this is our scatter plot. This is the residual plot. And this is a dot plot of the residuals. Okay. So let's move on. Now, with number 4, we're going to construct a 95% confidence interval for the slope of the population regression line. So I want to identify the parameter and statistic. Now with that, you should be able to do that. And then we will look at the 5 conditions. But we haven't learned all of this yet. So before we get started, I do just want to kind of tell you guys a couple of things. I'm going to go ahead and show this for you to look. You actually have this already printed on your paper. So parameter and statistic are right here for you to use for the first part. These are the conditions, but we define them in the worksheet, so you should be able to do it there. Remember, independent is your 10%. And then the main thing is I want you to see that your degrees of freedom is n-2. And then we'll use these 2 formulas for the interval and the test. So on this worksheet, I'm asking you to do that, so the general formula of an interval is statistic plus or minus critical value times standard error. So for that here, that would be B plus or minus T star times SE. It's T star, not Z star. So it depends on the DF. And it's N minus 2. Now everything else you should be able to find. Remember the B, the SE, they're in the table. And then the same thing for the test that we're asking you to do in number 8. The test statistic and the p-value. We have these formulas right here. Remember, the beta is 0 from the null hypothesis. And the TCDF is how you get your p-value. So pause here to complete that, and then you'll unpause to come back and see how it looks. All right, so number 4 for the parameter, don't forget to say true slope of the population LSRL, and then you put it in context. And then this is your sample slope from the computer output. Then here we were checking the conditions, so that, like I said, the independent condition is the 10%. The linear condition is we can look at the scatter plot or the residual plot, whichever one is provided. In this case, we had both, and so we did both. And then normal, we look at the dot plot of the residuals, and so we had the dot plot so far back right here, and there's no strong skew or outliers in that. So what we could do is just copy that down while we're checking, or just refer back to it. And so make sure you just look at the dot plot of the residuals. Equal standard deviation is about the residual plot not showing a sideways Christmas tree, so we want there to be uniform scatter in the residual plot. So that's what you have to say for that. We can pretty much just say that every time as long as it's true. Then you should be good there. If you don't have the residual plot to look at, you can't check that one. And then random. Oh, I forgot to check the random. So let me just make sure here I had a random sample. Oh, took a random sample of 9 students. So I'll just quote that, remember. And if you put this all together, what it spells is L-I-N-E-R, liner. So instead of having 3 conditions, we have normally independent or 10% random and approximately normal or large sample size. Now we have these 2 extra ones, linear and equal standard deviation. And so you just have to check all 5. You typically won't even have to do this, but just in case you do, those are the 5. And it's very close to the word linear, just without the A. So construct the interval. So I told you this is the formula that we use. And so this is called a T interval. I'm going to write that right here. T interval for beta, the population slope. And so this, and then the degrees of freedom is really important here. The DF would equal 7. And so to get that, remember, I use my calculator. Second, bars 4. This is a 95% interval, so 0.025. The DF is n minus 2. There were 9 students in the sample, so 7. And then my T star was 2.365, always positive there. And then your SEP is your standard error right from the table, 1.29. It was right here. And so we have our B and our SEB. And so the only thing for an interval that's different is that we have to multiply the SE by a T star. This is not the T star. So I'm just going to write that because we got 2.365. We know how to find T star. And then that gets us our interval. This conclusion is the same as always. We are 95% confident the interval from blank to blank captures the true blank. So it's always the same as before. Now, number 8 is just taking the same information and doing a significance test. So we're going to call this a T test for the slope, population slope beta. That's the procedure name. And our HO and HA, we use the same style that we always have, equal signs for the null and inequality for the alternative. I chose a greater than sign because it said positive. And so we have a lot of options there. This is always equals, which is no linear relationship. And then your alternative will be a positive one, a negative one, or just a linear relationship with a not equal to sign. Our test statistic, the formula, we had it written down, is T equals the slope from your sample minus the population slope over the standard error of the slope. And so this is always 0. And so we end up with 7.507 minus 0 over 1.29, and we get 5.819. And then same process as always, draw this normal curve. It's really the T curve, put 0 in the middle, label your DF, and then we use TCDF. That was second bar 6. Our lower was our T that we got 5.819. Our upper is 99999 infinity. Our DF was 7 still. Paste. And I got 0.0003. So that's my p-value. Okay, and then because it's a greater than sign, I don't double it or anything. And then this is our same as always. Compare p-value, reject or fail to reject the null, and there is significant evidence or is not in case you have a large p-value. Now I want to go back to that table and show you guys a couple of things. So this T, I said that's not the T star, it's the test statistic. Because 5.82 is what we got, 5.189. And remember, the formula equals B minus 0 over SEB. And so if we have, here's our B, 7.517, minus 0 is going to be 7.517 over SEB equals, so I'm just going to write that. The first number divided by the second number equals the third. And I can show you right here that we have 7.507 minus 0 is always the same, divided by SEB 1.29 equals 5.189, or 819, so 5.82. Then this is our p-value, close to the p-value. We got 0.0003, this is 0.0006. So this is a p-value if our alternative were a not equal to sign typically. It should tell you, if it doesn't tell you, we have to assume it's a not equal to. So remember, for not equal to p-values, we find the one way. TCDF, this, I'll just grab this. And then we hit times 2, and that's how we get the one that they got, 0.00065. 0.0065. So that's where that comes from. It's a not equal to p-value, so make sure that it's the double from the one side. All right, so let's see here. We were able to find it the way we always know how, but you can use that table to get those answers as well. And so I have this here again. I'm not going to say much more about it. Hopefully you already got it. And now I want you to try the check your understanding. You're doing pass for both. And so you're going to do one interval, one test. Make sure you check the conditions if it says to, and don't worry about checking them if it doesn't. Pause here to give it a shot, and then we'll unpause to check it. Okay, so here is this right here. There's one thing I need to fix on mine. I realized while I was doing this. The residual is histogram of the residuals. Okay, so anyway, here we go, T interval. So a couple things. I am going to cross out these top two. We never use them. Cross out that. We never use it. Remember, this divided by this equals that. You can check it out if you want to, but we don't need that for this problem. Just in general, that's what you got to do. And then hopefully all of that fit right in with your understanding of the material, because it's pretty straightforward. We've done this a million times. at this point, and now we're just applying it to linear regression. Every AP exam I've ever seen, except for the one in 2020, actually had one of these questions on there where they just ask you to fill this formula in most of the time. And so you just got to know that, basically, and if you do, you're probably good. But still important to know how to put it all together. Here's the next one. Now this one did say assume the conditions have been met right here, which means I just put that exact same thing right there. And then wanted to tell you, remember this divided by this equals that. And so I didn't plug it in, I just showed the formula, but you can also write it T equals 1.4929 minus 0 from the null hypothesis over. That's where you got that from. And now one other thing I want to show you is, remember this P, we don't use these, so I'll cross them off. This P is for not equal to HA always. And so in this case, we have a greater than HA. You have two options. You can take the p-value they gave you, unless they tell you otherwise, then we have to assume it's not equal to, and you can just cut it in half. Or what we can also do is just stick to the TCDF and do what you already know. So our T was 3.07. Keep the infinity there. And then our sample size was 38 infants, so we have 36 for our DF. Hit paste, and I got 0.002, which is the right answer, not 0.004. And so if we want a greater than HA, we have to cut that p-value in half, or like I said, just do it yourself with a TCDF. And then same as always, because our p-value is less than enough, we reject the null. There is evidence of a positive linear association. All right, so our last one hopefully made sense. Hopefully I'm back at school to help you out. And if not, you can keep asking for tutoring. Otherwise, have a great day. See you guys next time. And that's it.